Okay, guys, good morning. Let's wind up the course today. We'll finish off what we were doing last week. We had a couple of questions left from last week, and then I'll do views today, introduce you to views. That's what the course says, introduce you to what a view is, and then talk about normalization, right? Something that I've not been able to talk about, though I've been mentioning it over and over again. I'll officially do examples on normalization, and that will take care of the course. We've covered everything in the course. For the final exam, please keep in mind, joins and subqueries are the main emphasis of the exam, of the final exam. You will have a written, you can use your computer, your assignment, same format as midterm, plus, of course, advanced select statements, anything that you've done after the break, right? But that doesn't mean, oh, you shouldn't know how to create or use databases or create or use tables. I mean, that automatically stands. So get your MySQL server running. Please don't forget me to give your hard copy today. I'm only marking the hard copy. I'm not even marking the soft copy. The soft copy, as you know, the announcement said, was only to tell me that you had completed it. So I need the hard copy before I leave class today. Okay? Or if you still have to print after class, just come and give it to me in my office, right? And just slide it under my door if I'm not there. But after today, I'm not accepting it. So that's what I'll mark. I'm not even looking at soft copies. Don't forget your legends. If there is no legend, there is no mark. It already says so on Blackboard. Though it's only 2 marks of it in the rubric, but just so that you know. So I'll open the file that we were working on last week with you guys. So that's Thursday. And it was called sports. And it should be on Blackboard also if you don't have it. I'll just run it once so that I can show you the ERD, though I'm sure the ERD is available. So we were talking about some players playing different matches, teams, captains, and penalties, right? So that's what you had last week. So the legend, when you give the diagram to me, I don't want to print out of this. That's not what the 2 marks are for. The legend is what is important, because that tells me what each thing means. And I know nothing. I have no clue what it means, right? So don't just say, oh, you know what each one means. No, I don't. Otherwise, why would I be asking you? Right? So it comes to me today. It's the last day. Please put your name and your partner's name on it and submit it to me. And if it doesn't come, then it's just a 0 for that particular requirement. Okay. So I'm marking the assignment. I'm hoping that I'll finish by the weekend and I'll give it back to you. Plus, I'll put the solution on Blackboard so that if you needed to prep for an exam, you have it. So I'll put the solution on Blackboard. Hopefully, I'll remember to do it today. Okay, so of course, I have the solution. Also keep in mind, it's not necessary that if your result is right or is what is matching, your query is right. Maybe I've asked a subquery and you're using a join. You know what? So if the questions were very clear as to what was required, if you haven't followed the instructions, you don't get it. It's as simple as that. Otherwise, why would I say use an inner join or use an outer join or use a subquery? So if you've done it your way and you haven't paid attention to the instructions, I'm sorry, I'm not going to give you marks, because the whole purpose was to test you on good things. Okay? Who's Sam in my class? Do I have Sam in this class? Oops. Okay. Okay, any late assignments will not be accepted. I mean, almost all of you, 90% of the class did give it in class. There were two groups who gave it late. So I did write back to him saying that please see me about it. I mean, I can't accept it. If an assignment is late, that's what it is. It's as simple as that. But having said that, of course, things may happen. And if you have that assignment on your system and it is still backdated from the due date and you just forgot or something, I mean, things do happen, right? Then I'll still accept it. Okay, so that's how it holds. Also keep an eye on your emails after the final exam. Sometimes I had a group assignment that was given and it was 0 bytes. The file was empty. So I mean, I don't know how it was empty, but it came empty to me. So when I'm marking it, it's a 0 for me. But I, of course, wrote back to the student saying it's empty and do you have a copy of it? And if it is time stamped and it is not, you haven't done anything to it, I'll still accept. So things like, I mean, they do happen. So I'm kind of flexible on that. But the rule is if there is a due date, that's what it is, right? Oh, I forgot to do this or I made changes. Please accept my latest copy. I can do that. I mean, if I was doing that, I would do it for everybody, right? That's how it goes. Okay, so let's complete what we were doing here, and that will take care of our joins and subqueries, and there is no end to it. And I did see a couple of examples in class, which in the assignment, which I would like to maybe bring to your notice because they were new to me also. Please, one common mistake, which I hope you don't make it again in the final exam, just to bring to your notice, though you have to check the type of the variable. Any text data, if you remember in the instruction, it says is in quotes, numeric without quotes, and date in the format that you like, right? So the mistake that I saw kind of almost in 90% was that students had not looked at the type. So if it was a number like 3, warehouse is 3. 3 looked like a number. Of course, it is a number, but its type was character. So it had to go in quotes. Similarly, part numbers, order numbers, they were all numbers to look at, but their type was text. So if the type is text, please ensure that the data is in quotes. It's not a rule. SQL works with it. It's fine. I mean, it's at 23. That's fine. I'm okay with it. Unless it's really text DR93 and you haven't put it in text, then it will complain and it will think, oh, what's that? But if there is a requirement on the assignment that that's what you have to do, then unfortunately, I'll have to mark it accordingly. Or fortunately, you have to pay attention to all this. So as a programmer, and especially because you're programmers, I don't want you to go loose just because my SQL is loose. Okay, keep that in mind. Okay, so let's come to where we were. So this is what we were working on last week. As I said, I'll sum it up. Again, I don't know if you give me an ERD, what does 1 and infinity mean? What are these lines in the diagram? So the legend has to be very clear. You have to tell me it's a relationship, it's a one-to-many, one-to-one. And I told you, please double check because sometimes the ERD doesn't work with right diagrams. I've already seen it in one case. Okay, so here is what we have. If you do not have this file, as I said, it should be on Blackboard from last week. So we had done, we were on 3. I think did we complete 3? We said join, we said outer join, has less records. We did subquery, we did a correlated subquery. Oh, and let me tell you something that I noticed. I can't remember whose assignment it was. A group assignment did this. So the where exists was taken, and instead of where exists, it said where player number in. So it kind of looked like a subquery. You see, it is a subquery. It's correlated because you are comparing the player number, which is in the outer table, with captain, which is in the inner table. And it looks like a where exists, except the where exists has been replaced by where player in. Now, just so that you know, I mean, it worked because there was only a field here and you had only selected a field here. But if I had a star here, it wouldn't work. It will work otherwise. It will work otherwise. So if I look at these 2 questions or 2 solutions, so no database selected. Okay, seems like I'll have to just run the whole script. I didn't make any changes to the script. Strange, I didn't make any. It must have lost it. Okay, so I'm just running the whole script, and then it's too difficult to see where the answer is. So I'm going to pick up this one. And the question was, the question that I'm looking here is, get the player number of captains who have incurred at least one penalty. Okay, so captains and incurred at least one penalty. And the correlated subquery uses exists and not exists. So here 6 and 27 and 6 and 27. The answers are same. And you will say, oh, but we were told that in a correlated subquery, we only use where exists. Yes, you do, because you don't bother about this. You can give a star here and it will still work. It will still work. Because all you are saying is do a join and see if the record is present in that join. But if I do a star here and then do this query, it won't work. Right? Why? Because you're trying to say, oh, the player number is in this, but this is not in means you're looking for captain, you're looking for numbers in that list, which is not true. So you have to be careful when, I mean, of course, the student did it, the group did it, and I was fine with it because it worked and logically there is nothing wrong in it. But you have to be very careful that when you use where exists, I can replace the captain by because all you're doing is select all the records where this join matches, which is okay, just select it. And then look if this record is in there. So it doesn't say, oh, I'm only looking for a player number, so there it should only be captain. You can put a star and it will work. But when you use an in, then you're basically checking in a set of values. So it's not saying, oh, in the set of records, can you find this captain? You're saying, does this captain exist in that set of values? And you cannot replace the captain by star in this case. That's the major difference. So yes, both of them are correlated subqueries because the inner query is referring to the outer query, but there is a difference. When you say where exists, the inner query, you can just say select star. Really doesn't matter. You're doing an inner join. That's what you're doing. But when you're doing something like an in, please keep in mind that in basically means, oh, there is a set and I'm in that set. So that set has to be a value of sets. 2, something important, haven't seen a lot, but at least in 10% of what I've already marked. Don't write redundant code. You're joining a table that is not even required. That's redundant. Or you're writing a statement, select rep number from rep table where rep number is equal to 65. That's silly. Select rep number from the table where rep number is 65 basically means you're only selecting rep number 65. So pay attention to all this. You need to select you're writing a join which needs 2 tables and you have 4 tables joined. Of course, I'm going to talk of marks. So there is a efficient and redundant requirement and you have to think about it. It's not that, oh, it still works. Yeah, but it's saying, okay, I need to eat 5 apples, I'll buy 12. It still works. You know what I mean? So I need 5, but I'll buy 12 and it will work. Of course it will work. But that doesn't mean you're wasting money. Why should you buy 12 if you only need 5? So you have to be careful about these things, very careful. So I'm trying my best to return that assignment back to you before your final exam so that you can see where you went wrong, just in case, right? Because you will see similar questions in the final exam. Plus, of course, I'll give you my solution also. So I'll do that if I can remember today. I'll post it on Blackboard and I'll try to finish off marking and give it to you by the weekend, right? So that you have some time to prep. So I see you Wednesdays and Thursdays is when this class is. If we can do it by Sunday, at least you have 2 or 3 days to look at the assignment. But of course, the solutions will be with you if you need it. Okay, now we came to, so keep in mind about this. I saw one of the groups doing it and I was kind of saying, oh, where exists hasn't been used and they're still using a correlated subquery. But logically, since only one value is being compared with one value, it's not the most efficient way of doing it, but that's okay. Right? So efficiency, in terms of efficiency, I've seen in more terms of Why did you include a table if it was not required? Why are you writing statements like select rep number where rep number is equal to 65? Those silly things I've taken definitely into account for looking for efficiency and redundancy. But is right join better than left, or this would have been better? I've not paid much attention because, again, you're still learning, right? So efficiency is something that comes with practice. Okay, so this was done where only the player number was required. But then we said, let's see if we can do it if name and initials are also required. So doing an inner join, this is the one I have written yet. So this was using an inner join. So if you need the name and the initials, definitely that means you have to join another table, because the name and initials are coming from the players table. So I added the PL table. I could have said PL dot player number here and it would still have worked. There's no doubt about it. But maybe I think I just copied it and it remained at T captain. So this table is joined. As soon as you join the table, you will have an extra condition. So I added the extra condition. So then when I'm joining the table, I don't need a third condition which says, oh, captain should be equal to player number, because notice captain is equal to this player number is equal to player number. So basically they all three are equal. So I don't have to do an extra. That's redundant. Writing that would be redundant again. And saying that, oh, T is captain, or I'll just take this condition, is equal to PL player number. Not required. This third condition is not required because PL player number is equal to player number of P. P of player number is already equal to T captain. So this condition is redundant. Why would you need it? You don't have to. So be careful of not writing, because remember, the more you write, the more mistakes you can make. And of course, it is less efficient. And this is redundant. You've already checked it. You've already checked that captain is equal to player number of P and that player number of P is equal to player number of PL. So where lies the need to write this redundant condition, right? So you have to learn, because the whole purpose of programming is to create good and efficient programs. So that condition is redundant, don't write it. Okay, so that was using a join. Let's try it now using the outer join. We did one with outer join also. So here, that's the outer join. I said it is just because Teams table has less records, but really, I mean, it really doesn't matter just because we saw it. Okay, so I need the same thing here, but I need the name and initials also. So I'll just do one outer join. I mean, both can be done. It really doesn't matter. I'm just going to copy it. So this one is only giving me the player number. Now I want the name of I also want the name of the captain. So what I'll do is I'll do another join, right? So I'll do another left or right join. So this is already being done. You've already joined it, and I'll again join it with the players table, which was called TBL players. Right, and again, there are a few ways of doing it. I'll show you all ways, and you can say, oh, this looks more efficient because the first thing you're saying is, okay, I picked up the team. I picked up the captain from the team. Is the captain, has the captain made a penalty? If the captain has made a penalty, then give me his captain number, player name, and his initials. Right, so I just joined another table, but of course I'm missing the on condition, and the on condition is same as that you would have here. So you can write either. You can say PL player number is equal to the T captain, or you can say the PL player number is equal to, you can do any of them. Both of them will work. Should work. We can give it a try. Doesn't look as if it will not work. So you can again choose anything. You could have written PL player number is equal to player number, or you could have said PL player number is equal to T captain. They're both the same things. Whatever makes logically sense to you, because you're looking for captains, maybe this makes more sense to you. But at the end of the day, they are all equal. Right? So what did I do? I took my teams. I said, oh, there's a team. You are a captain. Did you make a penalty? If you made a penalty, what's your name and initials? And I kept the T captain in the distinct. You can write it as PL player number. If you want to be saying, oh, everything comes from the main table or one table. But really, that doesn't matter at the end of the day. So instead of this T captain, you can always replace it by PL player number or by P player number, because they all are the same. They're all same things, right? They're all the same. Notice how they're all same. So what I did, I already had this. I already had the captain coming from it. I added the two new fields I wanted. As soon as you add the two new fields, you definitely need a new table. When you need a new table, you need a new condition. And I just said, okay, the player number of PL should be the captain of the team. Or as I said, you could just do it with P dot player number also. And it should work, right? Hopefully it should work. I should have their names. So we had 6 and 27 as the two captains. I've shown you an outer join. And again, I did it with right join. There was a left join also sitting here. You can copy that too and add that condition. It's no different. And then I'll do it using a subquery. We'll do it using a subquery. So keep in mind, as soon as I need more information, then is when I need new tables. So let's see if our answers are correct. So the two people were R and 6 and 27. So 6 is R Parmenter and Collins D, and the same results. So it works, right? So having the EER diagram is a big advantage when you're doing joins and subqueries. I'm not sure if you've concluded that when you did your assignment. If you have the table, you have all the fields, you see the connections, you know their names. You can kind of not even in your head, you can see it. So you'll say, oh, this is what is related. I know how to work with them. Okay. So if in the exam I give you, I'm hoping that I can stick to the same tables that you did in your group assignment so that you've seen them. So get an ERD for that for sure. If I give you something else, I'll provide the ERD on the projector so that you can see it, so that you don't have to keep going back on your whatever, okay? Or maybe give an ERD one per table or something. I'll do that because it does help in understanding what am I interested in. So there it is, okay? So again, all I did was I needed extra fields. As soon as you need extra fields, you need a table if it is not already in the table. And this was only doing right join. I mean, this really doesn't matter. In this table, we can't say which table was bigger. So I assumed that table teams was smaller because it was smaller. It only had 3 records in it. Penalties was bigger. So I'm assuming, oh, this is more efficient because I'm looking in the smaller table. And then, of course, I know that the players table is quite big. So maybe here, instead of a right join, I should do a left join, just because players is a bigger table. So again, we try to keep the smaller table as the master table. So since players is quite big, I say, oh, let's use a left outer join instead of using a right outer join. So this is where efficiency comes into kind of action. Why am I looking in the bigger table? I already have a smaller table that is telling me this captain did this penalty. All I want to know his name. So why am I going the other way? Why am I asking each player, are you a captain? Are you a captain? Instead, I already know captains with penalties. What's your name? Right? So instead of a right join, a left join would work better because this table definitely is bigger. It tells you about all the players. So why would I look in all the players? I would look in the teams for captain. Did you do a penalty? What's your name? So this will work. There's no doubt about it. And again, I can. Okay, so the previous one was doing 15.015 seconds. The one that we just did. Let's see. What do we get here? Sometimes you get lucky. You see the time if it's really taking a lot of time. And that's 0 seconds. So that proves to you that's more efficient. And you have to think it that way. You have to think that if I'm trying to look for something, what would be a better way to look for that thing? Do I kind of look everywhere, or I'd only look where I think it will be? Right? So it's like you lost something and you're looking all over the house, though you know it is only in your bedroom. Same kind of concept. So the players table is huge. So if it has more players, why are you going to the players table and saying, oh, are you a captain? So you're kind of going the opposite way. Instead of saying, I already have a list which says captain with penalty. Captain with penalty, what's your name? Captain with penalty, what's your name? So going from a smaller list and looking in a longer list, of course, this will be easy. You're only searching for 10 people. Whereas here, if I went the opposite, you're searching for 50 people and asking them the same question, though the answer is only out of 10. And that proves it here. Notice how before, when I did a right and a right, I was, though it's not a big difference, but 0.015, and then I had a 0.0, which means it was less than that. And again, you have to remember, I'm only working with 10 or 15 records. In the real world, it's trillions of records. So it makes a difference. It does make a difference. So efficiency has to be kept in mind as a programmer, always, not only as database programmer. When you write programs in Java or whatever, you always have to think about efficiency. Should I put it outside the loop? Should I put it inside the loop? I have to do a printing only once. Why will I put it inside the loop? Because then it will do it every time. So small things matter. They matter in programming. They're important. That's why things are different. One car is better than the other. One software is better than the other because of how they were made. So the designing was done well, and then the issues of efficiency were kept in mind. And you all know about it, hopefully. Okay, let's look at the subquery now. The subquery, again, I had done it two ways. I think I wrote a normal subquery, then I wrote a correlated subquery. So we'll pick that up and we'll again put it here. It says, okay, I want the player number from the penalties, though you can do it another way, though it's not the best. I'll write it for you here also, because I see I didn't do it. You could have done it this other way also. Instead of looking for player number in penalties, you could have looked for captain in the teams where, in the teams where this captain was in. Select the player number. No, it was the. See, look at another subquery I just wrote. From table penalties. I could have answered my subquery this way also. So instead of saying who made a penalty and are you in the teams table, you're going the other way. You're saying, and here I don't need a distinct because there is only one captain in each team, right? So I don't need a distinct here. Here I'm saying select that captain from the teams such that that captain is in the list of penalties. And you can do a distinct here now so that you have a shorter list. Distinct will give you a shorter list here. So if a person has made more than one penalties, distinct will give you shorter list. You're only interested in who made a penalty. So if a person made 5 penalties, his number only occurs once. And searching in a smaller list will take less time. And you don't need a distinct here. Since captain is automatically unique. The captain can be a captain of only one team. I don't need distinct. And I should still have the answer, right? So I should still again have 6 and 27. That's what we are having, right? So let's check. So again, you can write the subquery also in 2 ways. You'll say which is more efficient. Again, will depend. This I think is more efficient because my table teams is smaller in size. Just because I'm saying, are you a captain first, and then saying, did you make a penalty? Right? So this subquery is more efficient. Because what's your interest? Your interest is the captains who made a penalty. So the first job is, are you a captain? That's your first question. The second question is, did you make a penalty? So this one is more efficient because for the simple reason that you're only looking for captains. So if this is more efficient, I'll just pick up this one when I add the name. So I've already said this there. I won't repeat it here. I won't repeat it here. Oops, seems like the spelling is wrong. Okay, so that is a more efficient subquery. Now I want to join name of the player and the initials of the player. Name and initials, was it name and initials? I've been doing it and I forget. Yeah, the name and the initials, right? The name and initials so that I can see what's the name and initials of this player. So if you already have the subquery, it doesn't take a lot of time to just add 2 more fields. Okay, so add the 2 more fields. Player number, player name, sorry, and initials. So I've added 2 more fields and I'm going to use the same one. Now in a subquery, the main thing to be remembered is that these fields that you are looking for have to come from this table, right? It has to come, because how does subquery work? Subqueries are kind of independent. So if they're independent and you're saying, oh, I need the player number, I'll have to change it to player number here. I need the player number, I need the name and the initials. This can only come from which table? It can only come from the table players. That has to be your first table, because the fields you're choosing is basically present in that table. So in subquery, you have to just go this route. You'll say, oh, that's not the most efficient, because the first thing I want to find out is, are you a captain? But remember, are you a captain is basically here. So are you a captain is coming from here. So what will I do is this, I'll have to change it. I'll have to change my sequence for the simple reason, because subqueries kind of work from bottom to up instead of top to bottom in a sense. So the first thing I'll do is I'll say, are you a captain? So I'm going to select the captain from the, that's my first job. Are you a captain? So select the captain from the teams. When you think subquery, kind of think opposite. I mean, you're not think opposite, right opposite. So that's my first job. Are you a captain? Right? My second job is I want to select all those people from the penalties table where this player number is in this field. And then here I want to select all those players whose player number is in this set. Oops, sorry. It's not platter number, player number. Okay, so my first job, are you a captain? So select the captain from the teams. Now select those player numbers where that player number matches the captain. It's in the same team. So if you think about it, this happens first, the innermost query. So this should give you all the captains, 627, 112. Then your next job is, oh, are you in the penalties table? Only 6 and 27 are in the penalties table. And now what's your name? There it is, right? So in subquery, you are still thinking the same way, but you're writing the opposite. So you're still saying, are you a captain? That goes as the innermost query. Did you make a penalty? Second subquery. What is your name and initials? The third subquery. Because the subqueries work from bottom to up. Because this has to work before this can work. And this has to work before this can work. Right? So it is still the most efficient. I'm first looking in the teams table to see whether you are a captain. Once I know you are a captain, then I'm saying, oh, did you make a penalty? And once I see you made a penalty, then I'm saying what's your name and what's your initials and what's your number. So there it is, using a subquery. And again, no extra tables, nothing. Please be very careful. I've noticed it in a couple of assignments of the 10 or 12 I've marked. And of course you will use marks. Like you're right. If I'm saying subquery, I need a subquery. I don't need to see a join. And I was very clear, subquery only. Because Only means nothing else. I know it can be answered using only a subquery. So guys, when it comes back to you, you have to be very careful and keep that in mind. Okay, so here it is using a subquery. Why it is important that the fields you select here come from this table, because this happens at the end. If you try to choose a captain and the captain belongs to the innermost table, it will give you an error, hopefully. Logically. God knows how the engine works, but there I have an error. It says unknown captain. And it makes sense. Logically, it makes sense. So what you select in the select, outermost select, has to come from the table of the outermost, because each of them is independent. So I would recommend, you've done quite a bit of, I'm hoping quite a bit of work in your assignment. As soon as you get a question, you say, what do I need to do? 1, 2, 3. Kind of do this, do this, do this, and then change it into a code. Like write a kind of a pseudo code. Okay. So you had 18 questions in the midterm. Of course, I'm not going to give you 18 in the final. It's too much to do in 3 hours with one head. But I'm expecting somewhere around 10-ish. Okay, so around 10 is what you're looking at the final exam, which is okay for 3 hours. We do much more, but we do much more just because I'm prepared with it. Therefore, we do much more. You did much more because you had 2 weeks to do it and you had 2 partners. So keeping that in view, I'll kind of try to stick to 10 questions, but don't forget your everything that you've done. We've done count, min, max, group by, having, year functions like date functions like year, month. You can't forget any of those. That's all new that we did after the midterm, right? All advanced select statements. So dates are important, and I'm going to do a question on date just so that you remember it. Again, since the subquery can be written in 2 ways, I had written it in 2 ways here. I can, of course, show the answer also in 2 ways. I had written it in 2 ways. I said this was more efficient, and I said this was less efficient. Definitely, I can do it this way also. I mean, the same thing, you only have to pick it up and do it. But in each one of them, I've just picked up the more efficient one and given you the answer. So inner join, there was only one. There is no efficiency or not efficiency in inner join. I picked up from outer join the efficient one, and also from the subquery, I picked up the efficient one. Now let's see, can I do it using the correlated subquery? I'm not sure. I have to look at it. So you're saying select the player number. I think we can try. It doesn't look like logically you cannot. If you can do this, you can do that. Let's try it. So using a correlated subquery now, and I could be wrong because I'm just trying it. I didn't think about it. Okay, so here you were saying that I'm looking for such a player number that exists in here. Okay, let's try it. Now I have to look for the player number. So that's the extra thing that I have to work with, right? Okay, so I'm interested in all those players, player names and initials such that, oh, I need a join. You always need a join in the inner one. Because as soon as you say where exists, I mean, I can do that in thing that I just showed it to you. A group had done it. Let's try. I'm giving it a try, okay? I think logically. So you're basically saying this outer table needs to be it's like a subquery. All you have to do is you have to kind of match things where the table players, I'm just going to give them names, right? P for here and PP for here, or PT you could call it for penalties. And table teams, I don't need it. Okay, so this one should match the PT1. This one should say PT dot player number is equal to P dot player number. It's just a joining. And again, I'm just trying it. It just because I'd written it. And all this I can replace by ins just because it doesn't like it. It doesn't like the it doesn't like something. What doesn't it like? This should have closed here for sure. And this should have closed here because it's not a subquery, but it doesn't like it. Does it tell me anything? Syntax is not valid input at this position. Seems like you cannot have where exists twice. Of course, I can change it to where player number in and it will start to work just because there is only one player number, but it doesn't like the where exists twice. Just in this question, because you're only selecting the player numbers, I can say where player number in. Just in this one, and I can say where player number in. No, let's try. Who's coming now? It's kind of difficult to put your head around, but I'm just trying to do it. Where which player number is in now here? PT dot player number. Which is basically doing two ins. No, it doesn't like it. It still doesn't like it. Okay, cannot do it using sub. It still doesn't like it if you have two wheres at different positions because it says where must come together. It's in a way saying select where from this and then from this, but they're kind of related and therefore it doesn't like it. Or maybe if I say no. Oops, okay, I take back my words, guys. Syntactically, if it is not correct, there's no sense of saying, well, logically it looks okay. When I can do it syntactically, thinking logically is not a big deal. Okay, let's do the last question now. The last question says, and this was just so that I could refresh your memories about date. It says, get the numbers, name. So player number, name and initials of the players who are older than R per mentor. So I'm basically looking for people older than R per mentor. You can assume that the combination of name and initials is unique. So what I'm saying is there is only one R per mentor. Why? If I didn't do that and there are two, who are you older than? Which one are you talking about? Right? So therefore, this assumption that is given is that there is only one R per mentor. The combination of initials and the name is unique. Though we know that names are not unique, but the initials, they're just saying maybe the middle initial or whatever. Okay, so who is older than R per mentor if his birth date is less than the birth date of R per mentor? The guy is older, right? So let's see. So there's a subquery and there is a join. Both can be written. I don't know why I've written it in the opposite, but that's okay. We'll do the subquery first. So select the player number. The name and the initials from the table players. It's not a join. It's not as if, oh, you need it. I mean, in a subquery, why have I done a join? We'll talk about afterwards. But what I want is the number, name, and initials of all those players where their birth date. I think it was called birth date. Yep. Now keep in mind, I don't have to put a cast in front of a field. It is already a date field. You put cast in front of a value. So if I was checking something like 01-01-1982, and that is a text. So if I'm using text, then I say cast it as a date. You don't put cast in front of it. It's not required. It's useless. What's the meaning of this? Cast the birth date as a date. Its type is already a date. Right? And I saw it in somewhere. I've seen it in some assignment. I don't know where, maybe in the midterm. So this is useless. You use casting when you're casting something that is not a date. So for example, I wanted it in here. So if I was saying 01-01-1982. Now this I want to cast as a date. Why? Because this is a text field. Be careful. Casting a field into date, which is already a date field, is ridiculous. But when I say please cast your dates before you use them, that's what I mean. You've written it as text, and now the text is date. Looks like a date, but I could put anything in a text and it may be an invalid date. So I've said take that and then cast it as a date. So when you use the cast function, don't use it on a field name, which is already a date. You use it on something that's not a date. And you could have used it here also if you were using it as a number. And of course, numbers don't have quotes. So when you take data, which is literal, and you want to use it as a date, that's when you cast it as a date. That's what I mean when I say cast date as date, not the field. Okay, so select the player number, the initials, and the name of all those players where these guys are older than. So if they're older than, their birth date is less than. Whose birth date? The birth date is less than. They're all older than our parmenter. And we've already kind of made that assumption that, oh, that guy, the names are unique. The combination is unique. So select the birth date. Oops, sorry. From. We again have the same table because he's coming from the same table. And that will kind of give you an idea of why have I written a join. So select birth date from players where the player name is parmenter and the initials are R. Capital or small really doesn't matter. We know that. It's not case sensitive unless we make it case sensitive, but there. So these are guys who are older than our parmenter. So the same table is being used twice. Once inside the first one. So we get the birth date of our parmenter, and then anybody who is older than our parmenter, his birth date will be less. And it says the solution should not display our parmenter. So I didn't say less than equal to, I just said less. If I say less than equal to, they're not older, right? They're not older. They are the same age as our parmenter. So I don't need equal anyway. So if I do an equal, I will see our parmenter, and I will also see all people who are the same age as our parmenter. The question just said older. Now, if I'm using the same table, so I don't know how many, though I know because I just did this yesterday with the other section. I think 10 records come up for this. So 10 people are older. How did we find if the answer was correct? We wrote the opposite, who were younger, and we added them. In the younger one, you will only take the opposite. Now, if I'm using the same table, can't I do this? If I'm using the same table, then basically I can do a self join. And what is a self join? A table joined with itself. As soon as you do this, you will have to qualify them. And it really doesn't matter from which table you are picking up because it's the same table. But you have to qualify them. Now you have to be very careful about self joins. So most of you, 95% of what I've marked is correct. But again, I would like to bring your attention to something here. Now, what's your condition? Your condition is that the birth date of the first person, I mean, you can assume the second or the first, whatever it is. The birth date of the first person is less than the birth date of the second person. And there is another condition. We haven't yet finished. And The name of the second person is Parmenter and initials are R. So the player name, since you're saying the birth date of the first is less than the birth date of the second, that means the player name of the second is P2 and his initials are R. So here you have to be careful where to use P1 and P2. Here I'm using P2 because I'm comparing the first guy is less than the second guy, and the second guy is whose age I'm trying to see. Right? Now tell me something. Just at looking at it. If I've already said P1 birth date is less than P2 birth date, is it necessary to put this condition at line number 358? It's redundant. I'm saying it should be less. So it is, if it is less, definitely it is not equal. And I've seen this in the assignment for the question 5, which was on self-join. I said, I don't want to see the same pair twice. So you can either use less or equal in that, but you're again saying and they are not equal. If something is less, automatically it is not equal. So again, it won't give you, it won't give you a wrong answer because you've just put an extra redundant condition, but definitely this is redundant and you will lose marks here. So it's redundant. You're saying it is less. If something is less, it automatically is not equal to. So don't put stuff where you don't need it. And that's what I mean by redundant code. Okay. So the date, now here you could have used P1 or P2, doesn't matter, in your first line at 355. But in 358, you have to use P2 because you're trying to find out all those people who are less or who are older than, so their birth date is less than the birth date of R Parmenter. So this is important that you use P2 here because you're comparing, look at your comparison, you're saying birth date of P1 is less than the birth date of P2. And P2 is the guy who you're comparing against. So his name and his number, his initials and his name are Parmenter R. So this should work. We should have the same answers. So 10 records should be returned. And there they are, the same persons. So join, you said, what are you joining? You just need one table. Yeah, I needed a table, but I needed it twice. So don't forget your self-joins. Definitely there will be a question on self-join in the exam. Because you should say, oh, can I do it? Would like me to do a self-join. And there won't be any hints in the exam, of course. In the assignment, I've given you hints. I've said, use a self-join. Or I've said, oh, if something is less than 1, it is less than all. So I've given you hints in the questions, in the assignment, so that you can put it in your head. So all, any, that's 2 new verbs that you did in your assignment in questions 15 and 16. So anything that you've done in class or anything that exists in MySQL, even if you haven't seen it before, can be asked. You will be allowed to use the manual, the MySQL manual. Nothing else but the manual. But I'll keep it simple in the sense that, oh, I'm not, if there is a question, there will be one tricky question, as there was last time and there was a case statement. Okay, so that's taken care of this assignment or this classwork. But in the same one, I'm going to do a view for you. Or we can create a temporary table. So I'll show you how you can create temporary tables or create a view. And what is a temporary table? It's a table that you require for some time maybe. It's not actually a table that you always want in the database, and then you can throw it off. That means you can drop it. Right? Till now, whenever you've created tables, you've always given the create table command, you've put your fields and so on and so forth. But tables can be created in other way. Right? There are a few ways. You can actually do a union of something and create a table, or you can do something like this. So I'll just pick up any question from here. Really doesn't matter which one I pick up. So suppose I'm saying the names and player numbers of players who have made a penalty. That's what I'm interested in. So I'll just use an inner join here. It's just picking it up. And let's see how can you create a temporary table. And what is the use? You still have the create table command, right? These are people who have done penalties, captains who have done penalties. Here, notice what I've done. What doesn't it like? Because the semicolon is missing here. Here, I've created a table called table captain penalties. You'll say why? Just because maybe this is required over and over again, right? I have to look at this. There is a list of maybe, or maybe it's not captains. Maybe the one that was more, a better example would have been all players who made penalties with their names and initials, right? Maybe that would have been a better example. But here is a table which you kind of need over and over again. You don't want to, of course, create a new table for it and put all that information that is already present. But what this will do is it will create a table for you. And if you want to see its structure, remember your, what was it called? Display structure, was it? Or show structure. I think it was display structure. No, it wasn't display. How did you show the structure of a table? If it wasn't display, describe. Describe the name of the table. So what has happened actually is a physical table. It's not as if it's not a physical table. A real table has been created. You can show the show table once. Show tables command. A physical table gets created in your database and it stays there while you need it. So sometimes while you're working on an application, you need to have a table just for your application because it's just easy. Instead of writing this over and over again, instead of writing this query over and over again, suppose you're running it many times, or this is a table that you would like to have just for other queries that you're answering, you can create a temporary table. I call it temporary because you can always drop it. Let's run it. And of course, before this, it's always a good thing to do drop table if exists. Though there may not be. Okay. I would like to show you that, yes, it does get created. I want to show you its description. You can do a select also from it. Here, let's do a select also from it. And it has a physical existence. So the table gets created. It will have the same fields that we just saw. So here is its, so it has three fields: captain, player name, and initials. How did it have these three fields? Here, that's where they came from. The three fields, right? What are their types? Int 10 unsigned must be in the captain. Player name coming from whatever table. Character 3 coming from whatever table. All these rest of the things are coming from the tables from which it is drawing its value. What are its contents? These are the players who made penalties, right? And it is a physical table in your database. What is the use of creating temporary tables? The use of creating temporary tables is basically if your application needs to work with the query often. So you say, oh, I have to work with this query over and over again. Instead of just writing it, copying and paste. I know it is a copy and paste, but if you give it a name, it gets existed. And now if I want to do something with it, I can say, show me, I mean, it's a small table, so I can say select star from it. If you remove the distinct, maybe, if you don't want distinct, then you will see it twice. Then maybe here you can say select star from table penalties, or you can say something like select everything from table penalties, where you can add a condition where it's just a normal table where captain is equal to Remember, we had 6 and 27, where captain is equal to, say, the guy 26, I had 2 penalties, or 27 had 2 penalties. So the captain who has made 2 penalties. Right? So I'm interested in how many penalties were made. So it's just like a table. The advantage is that you wanted to use this subquery over and over again. So instead of so here, this is made by 27. I removed distinct. So you see 3 of them, and here is its structure. Here you can say distinct if you like, but it's saying all those records where it was done. Right? So it's just a normal table. The disadvantage is it physically takes place. It physically exists and takes storage in the database. If it's a small table, you'll say, oh, I don't bother, but it could be a big table. Who knows? Like, we don't know, right? But that's its disadvantage, that it is physically a table and it is taking space on your server. That's okay. Now, if instead of this, if I could do something like this, I take the same thing, do a copy here. Oops, seems like I didn't copy the right thing. Oh, I removed it. Oh, God. Okay, so I take the same thing, do a Control C, and then do a Control V. Now, instead of creating a temporary table, I'm going to create a view. And a view is just a definition. A view is just a definition. It's not a, it doesn't have contents, right? So the view physically, when I say physically exists, the definition exists. And does not, I mean, it does not take storage like a table. And does not have contents. It's not a table. It's not a table. So look at the advantage. It's a definition that you've created. So how do you do it? You say create a view. I'll just call it, instead of TBL, I'll go view. Right? I'll just say, if you have a view of the same, drop it before. I mean, you can do the same things that you did. Now, when I do a view, when I say create a view, it is just a definition that it has created, which means anytime when you use it, when you use this view, that's when this subquery will take place, get the results and show it to you. Otherwise, only the definition that it is actually a select of whatever is in the database. So you will see it in the database as a view. When I say show tables, I'll say show tables. It will come up because show tables shows views also. But take my word for it, because there is no other way I can show you. Its definition gets stored and it does not have any contents. So when will it become active? It will become active. Let's see what happens in describe. I don't even know what it will show you, the fields and everything. But now it only becomes active. So here is where the view becomes active. When I say becomes active, it means it is executed. So the definition is executed. So what was the definition? The definition was saying, oh, select this from this and so on. There is where it gets executed. So the difference, if you kind of theoretically, I can explain it to you, because physically, how can I show it to you? Because as I said, it will appear in the show tables command. But theoretically, I can only explain to you that the difference between creating a table and creating a view is this. The table has the records in the database. So suppose it has 100 records, it stays in the database. View is just the definition of how that table will be created. So when you need it,
When you need it, that's when the penalties view is executed. So view becomes active, definition is executed when it is required. And see, you require it now. You are saying select star from the view. Select star from the view. So now here is when it gets executed. Here it's only a definition. It's like your class definition. You are programmers. So right, when you define a class in Java, it's just a definition. When you really want to use the class, what do? You create objects of the class. Same kind of concept. So there is a definition, there's a blueprint. Oh, this is what it means. But when you actually need to use the blueprint, when you construct a house, then it's different from the blueprint. So saving a blueprint is like just a piece of paper or pieces of paper or sheets that you're putting in your locker. That's my blueprint. When you want to construct the house, you take out those blueprints and you design your house. Same with cars. Cars are designed. They have a design, but they don't exist. Physically, they don't exist. The design exists. But when you want to buy a car or when the company wants to manufacture cars, that's when the design is taken out and the cars are manufactured. That's the difference between creating a table which has a physical existence with data in the database and creating a view which is a definition and only has the existence of the definition. It only becomes active. It is only executed when you need it. And then of course, it is when this select statements are just on the go. These are all temporary. We know that none of these are saved anywhere. You see the result and they are gone. So that's the difference between views and penalties. So they don't look very different from each other. They don't look very different from each other because they do the same job. They're trying to say, oh, I'm trying to keep this definition under a name. But the major difference is one has a physical existence and takes space in the database, and the other one is a definition, and just the definition is taking the space. It's not data, it's just a definition. So I will still have the same answers. I will still have the same answers. See, nothing has changed. I can see the penalties table. I can also see the view. I can still see the 27 colons. I can still see the 627 and so on. But the difference of a view from a table is one has a physical existence with the data. One only has an existence of the definition. So create views. Views can be created and they're helpful. Why? Because you don't have to physically create tables. You have already 10 tables, but you want to pick up some fields from some tables and kind of make a new table, but not make a new table. Just say, I want to pick up this field so that you don't duplicate your data or anything. You create a view, give it a definition, and that becomes a kind of a table for you, and you can use it as if you were using a physical table. Right? So it's basically a joins or subqueries from different tables that does a job that you repeatedly do. But instead of just writing the same code over and over again, you kind of put it in a box and you go whenever you need. Okay, that's what a view is. So views can be, you can select from views. Definitely notice I can select from views. You can also update. You can update and delete data from the underlying tables in a view. But there is a big but there. But it is not recommended, just because there are many rules. There are constraints on the view being created in that case. So I said it's like a table. It just has no physical existence. So you say, oh, if it is a table, I should be able to select from its shirt. I should be able to update and delete letters from its shirt, and it can be done. There is nothing that it cannot be done. But if you have to do update and deletes from the underlying tables in a view, you have to basically kind of you do some constraints. You have to say, oh, none of the fields can be null, for example, or so on and so forth. So there is a long list, not a long, but there is a list of rules on the view if you cannot have group by and having in that view. So there are certain rules that have to be imposed on the view if you want to do updates and deletes in the underlying table. When I say underlying table, the tables that are involved in the view. For example, here there were 3 tables involved, right? There were 3 tables. So there you can update and delete records in them, but then the view that you create has to have certain constraints. And one of the constraints that I can remember is you cannot have group by and have. That's one of them. And there was something to do also with null fields or something. So because there are constraints, it is recommended that if you need to update or delete tables that are involved in a view, just do the normal updates and deletes as if you do them with a table. Don't do them through the view, right? But they can be done. But that we are not going into all that just because it's again a whole topic. I'll need 3 hours to kind of do examples and all that. And it's just not in your course also, kind of. But yes, you should know what a view is. You should understand it is a definition. You should understand that I can use it as if it was a table and it has contents in it. You can do selections from it. You can update and delete data from the underlying tables, but it is not recommended. So it's just a definition that exists in the database. So it has, the definition has a physical existence, not the contents of the tables, not the contents of your subquery or query or whatever. And it is very useful. Why? Because if you're working in a database and it has 10 to 15 tables, and you just want to create a view that picks up data from maybe 5 or 6 of them based on some condition or conditions, and you don't want to create a new table, all you do is create a view and then use the view like you would using a table. Because we never duplicate data in a database unless really it is required. Okay, that takes care of subqueries, joins, and views. We'll take a break here of 20 minutes, and then I'll come back and conclude my course with normalization. So I've put a file called normalization.zip under your weekly learning, right? I would like you to pick it up, unzip it, and then we will go through the examples. I made the examples because I knew I wouldn't have enough time to do it. I would just have an hour after the break. But I'll go through the examples with you and tell you what is normalization. 1, 2, and 3. There is 4 and 5, which is not in the course, and Boyce Code, of course, which is not in the course. But that examples are ready. Normalization.zip from weekly learning. Unzip it, and we will work on it after the break at 9:35. Should take me around an hour or so, and then we'll kind of conclude it. Okay. So I'll do normalization officially with you today. Now that you know your joins and subqueries, it will make more sense. Okay, and I'll put this on Blackboard for you. Yeah, sure.
Can I give you my ERD?
Sure. You have your name and your partner's name on
Yeah, I'll
it.
put it on there.
How will I know? And of course, the legend, right?
Yeah, the button's right there.
Thank you. Guys, don't forget your name and your partner's name.
Did you want to discuss my assignment now, or did you want to go to your office hours?
What's your name?
Allie.
Oh, right. So you said that your partner didn't contribute anything.
So I have all the messages we ended up talking over Facebook instead of emails.
So shall I email him and ask him straight if that's okay?
Yeah.
I mean, I didn't talk to him. I didn't know whether he wanted me to talk to him.
Well, I wasn't sure if he would mark it without me putting his name on it, and I didn't want to hand it in with only my name on it and then email you, say he didn't do anything, and then it turned into like academic misconduct.
Yeah. So shall I just ask him that Ellie has mentioned that you did not contribute anything to the group assignment?
Okay.
Is that okay?
Yeah. He ended up, I think he ended up doing it, but he emailed it to me after the submission date, so I had already submitted the complete assignment because I didn't want to miss the deadline for it. So
he did send you the completed assignment?
After the date though. So everything I submitted to you, I did completely.
And before that, he wasn't answering any emails or anything?
Not really. He was saying he had issues. He wasn't understanding some of the questions and things. And we were actually supposed to get together at the library, and he didn't show up. So that's when I ended up doing the second half because we had split it up. So
you divided it this way, your first half and second half?
Yeah, I had done the joint submit originally, and he had done the subqueries.
That wasn't a good idea, but it's good that you did it because they're two different things. That's why I said when you divide it, maybe do half or half.
Well, we were going to get together and just do it together, but because we just couldn't actually physically get together, I thought it'd be easier than having to discuss it over email.
Okay, so when he sent you, after the due date, when he sent you the email, was it complete, all 16 questions?
No, he had missed one or two of them. And I didn't check to see if it was right because he had just copied it into a Facebook message and it was past midnight. So I had just kind of looked at it.
Okay, so it was past midnight. So he sent you something, but that was past midnight. He didn't turn up in the meeting that was set up in the library.
Yeah, he didn't show up.
So the work that is submitted is entirely yours. Yes. Okay, so I'll email him.
Okay.
And I'll make this clear that he won't get marks first. Okay. And let's see what he says then.
Okay.
Okay?
Okay.
But
Thank you.
no problem. But yeah, I will give you your marks, even though I said I wouldn't accept individual one. But yeah, but that's okay. It's not your mistake.
Okay, thank you.
No, like, just give up.
Thank you.
Like, I had this stat, so and the same thing with index, it just stayed in the index, it's not being shown. This is what happens. So I'm just gonna fix it up. I'm sure it's just my whole.
It's not easy to figure out. No. I'm sure it's a lot of work.
Not going. Are you serious? See you guys next semester. We haven't got that end of it. You just gotta go. I want to build like not we can raise it. That's what I want for my Yeah, I know, it's really nice. See, you did it right. You got a good shit desk. Always on my computer.
Yeah, tell me about it, but here's the thing, if I had to make another work, anything else worthwhile, I'm not immediately situated at my desk. I just got another one. I got 124. One for the game, one for a stream, one for websites. Neither of those three.
What's it you both know your achievements?
Wow.
I just have I one monitor divided in metal, so I just like polishing that have a website.
I was on Windows 10 gig. I just ripped my answer.
Oh, I thought you left.
Want to go make sure there's no ticket. This weekend, man, I'm gonna install it, so
Actually, like,
pretty good about it.
the seven was fantastic. This isn't
I just haven't found I have it on my phone.
This was, let's be honest, this is the best song.
I think it's best.
Windows 8. Windows 8.
Oh, shit. The group assignment. Yeah, yeah, this, but I know where it's from, I just don't know why it's doing that. Because I was updating since you never had people do that first thing, but right now I updated the address.
Go to your files, open up the header. Try to fresh it. Do yourself good. Oh, I did that. It's fast. The broken caption. Yeah. Oh, weird. Just try to shoot fire. Just keep on.
Okay, guys, open up your normalization folder and then all the files in there, we'll go through it one by one. Oh, I forgot to put this, I will. So just open up all those 6 files, I think there are, and we'll go through them one by one. Okay, I've been mentioning this right from day one, that designing a database or designing the tables in a database, when I say design, I mean what should be the tables, what should be the columns in those tables, is an important and the first step before even you start coding. And it is very important issue, and developers are different from designers usually, but they can be a combined team also. Why is it important is something that you have to understand. If you do not design, if your foundation is not good, think about it from any point of view. Why only databases? If your foundation is not good, whether it be your education, whether it be your house, whether it be anything, if the foundation is not good and not strong enough, of course it will fall down, right? So if your house may fall down, if you haven't put in much effort into your education and you don't have a strong foundation, you won't be able to rise because you don't understand the foundation or the concepts and you can't put them together. Similarly, in databases, same kind of concept. If you do not create good tables, and when I say good tables, I mean in terms of their structure, they will fall apart in due time. You may not think of, oh, what is the size of the fields that I need? What are the fields that I need in it? What is the data that I need in it? Depending upon the data, you decide the fields. And in the long run, you will ultimately have to change the structure, which is not easy once the database is up and running. So designing tables in a relational database is a huge and big concept. And therefore, there are rules that need to be followed when you design a table or tables in a database. These rules come under the category of normalization, right? And there are 5 normal forms. They're called 1, 2, 3, 4, 5, or first, second, third, fourth, fifth. And then there is a Boy-Scott normal form after the guy who created that normal form that helps a developer to say, oh, this is how I must design my tables. So today's aim in this hour or so is to kind of look at the first 3 normal forms, see why they are important in the terms of, oh, if this was the case, what were the problems that would have come up, and then learn how to convert a table that is not in a particular normal form to its required form. But the question is not here, oh, that's too much of work. The main emphasis here is if you design well from stage 1, then your maintenance is going to be easy for the rest of the life of the database. But if you do not design your tables well from day 1 at the beginning stage, then you're going to have problems. You'll keep altering your table over and over again, or maybe have to just drop the tables, recreate them, populate them with data, and so on and so forth. And that's all time consuming and maintenance. And of course, money, time and effort, right? So what I'm going to do is I've kind of given you 6 files here. One are called not and one is without the not. So I'm going to start with the first one, which you have seen and which we followed throughout our semester. We've always created our tables in the first normal form. We've always done that. But officially now, today, again, I'll define what is the first normal form and show you a table that is not in the first normal form, and then show you how to convert it into a table that becomes the first normal form. The process of conversion itself will be so time consuming, you'll say, oh, that's not worth it. But of course, if you had started right, you wouldn't have to waste all that time, right? So let's look at this table, and here is the definition. It says a table is said to be in the first normal form if it has a primary key, and there is no repeating group of information or data in any column. So when I say repeating group, I don't mean like duplicate, I mean repeating, like favorite sites. All your sites under one column, right? So what I've taken here is, I've just kind of worked with some databases. And again, if I can't run the program, I'll have to change their name or whatever. And here is a table that's present in it. It's a very simple table. It's a table about toys, which has a toy ID. It is an auto increment field, though you notice that I have inserted 5, 6, 9, 12 here, which you can do. You can always, even in an auto increment field, you can insert values yourself, though if it is an auto increment, the best thing is to just leave it alone, right? So some people prefer auto increment primary keys because then they don't have to bother about putting values into it. But it is possible, you can do it. It has to be unique for sure. And you can make it unsigned. Let's make it unsigned because it's kind of odd that the ID will be a signed one. So we'll make these changes as I go on. So it is unsigned. The not null is not required because primary key itself is automatically not null. And I've made it an auto increment key. But that doesn't stop me from putting values into it. You know that. Though we kind of say leave it alone, but we can still put values into it. Okay, so what have I done? I have a table which has toy ID as the primary key. So one requirement is satisfied. The name of the toy, varcat 30, and then the colors in which it is available. So for example, look at it. It says 5 wiffle ball is available in white, yellow, and blue. The frisbee is available in green and yellow. The kite in red, blue, and green. and the yo-yo in white and yellow. Looks like a perfectly fine table. I can do a select all, but look at the colors field that has repeating group of data. It has a repeating group of data. Now you'll say, that's okay, what's wrong in it? Let's look at what's wrong in it first. Like, what problems will I arise? The first thing, I want to select data and I want to see, say, for example, which toys are available in the white color. Now, of course, you will pick up the colors field. You know it is a varchar. You will use a string function to split it. Then you will search the split list and say, oh yes, it has white in it. So more work. If it was a single field and said white, all you had to say was, is color equal to white? But now you have to fetch the field. You have to split it into, God knows, it could be anything, split it on comma. So we don't know how many, but split it on comma and then search if white is one of that splitted value. So more time in searching. 2, I do not know, I have no idea what would be the appropriate size of this field. Some may come in 3 colors, some may come in 5, some may only be a color. So I'm kind of saying, oh, I've done 40, but suppose the colors increase for a toy and 40 is not enough, then I'll have to maybe go to 60 or to 70. So I'm not sure, because I'm not sure of the nature of the data. As a designer or a programmer, I won't be able to give it an appropriate size. You could say, okay, why don't you just go color 1, color 2, color 3, color 4 and make them 4 or 5 different fields. Yeah, but then again, the question still stays there. The question still says, if I have to look for white, I'll have to say, is color 1 white or color 2 white or color 3 white? I'm still doing more searching. And 2, how many fields do I make? Again, because I have no idea of the number of colors a toy is available in. So when you see a repeating group of information or data in a field, that definitely means it's not a good design. So you have to do something about it. So what is that something? You have to restructure your table. So let's restructure this table. And to restructure this table, so this should run, it's just a normal, as I said, unless it's my laptop, which we are okay with, it's just a normal table and it's quite useful. If you look at it, all information is available at one place. Very quickly, I can look at it. But remember, this is just for displaying purposes. If I only wanted to say select toys with color white, definitely I'll need more work to do. Because white is not just a field, it's in a group of a field. So extract it, use a string function, remove it, split it on comma, see what you have, do you have white, and then print it on the screen. So more work. So now to convert it into a table, or into tables, I should say, in the first normal form, I'll have to do some effort. What will I have to do is this. So, oops, now this is in the first normal form. So let's change the name. You don't have to necessarily, but that one was not, so I should just say it is in. So that way, at least the names are okay. So when I recognize them, though I don't need them after today, but when you recognize them, oh, this is a database with first normal form. Let's look at what I did. The first thing I did, I created 2 tables. I created a table called toys, and the toy ID was an int unsigned. I'll stick with the unsigned, and I don't need the not null. Auto increment primary key. Same concept that I did in the first one. And the toy name is varchar. I removed the colors from it. I removed the field. For the colors, before I started doing the colors, I created another table called table colors, in which I created an unsigned int key again, which was auto increment primary key. And I had a color field, which was varchar 10. You could go 15, right? Colors, like, I'm just saying 10. I'm not thinking of like combinations of colors. I'm just thinking red, blue, green, yellow, white. So 10 is good enough. You could go 15 if you like, right? Now, once I have this information about only toys in a table and only colors in the table, I create a third table, which I have a toy ID and a color ID. So now this table is saying that this toy ID, and make it unsigned, please, because it is going to pick up its value from, it is a foreign key. And when it is a foreign key, it has to have the same Oh, and it is not null because primary keys are not null. So I only have two fields in this table, toy ID and color ID. Toy ID alone cannot act as a primary key because it's telling you which toy is available in which color. So the primary key is the combination. And both of these are foreign keys. The toy ID is drawing its value from the toy table, and the color ID is drawing its value from the color table. Now, if you look at the tables, here is the toys, simple name, toy ID, name, toy ID, name. You look at the colors table, it just has white, yellow, blue, green, red, and orange. The color, the primary key is 1, 2, 3, 4, 5. I didn't bother to put any values into it. And now look at the third table, which is not very clear at all. It says 5, 1, 5, 2, 5, 3, 6, 4, and you'll say, what's that? It's giving me no clue. But it is saying that toy number 5, which is a wiffle ball, is available in color number 1, which is white. 5 is also available in 2, 5 is also available in 3. And look, why did I make the primary key the combination? 5 alone cannot act, the toy ID alone cannot act as a primary key because there are duplicates. A toy can be present in more than one color. The color cannot alone be a primary key because there are duplicates again. So what is my primary key is the combination of toy ID and primary color ID. Now, all these three tables are in first normal form, right? There is no ambiguity. Does the first table have a primary key? Yes. Does it have any repeating data? No. Is the second table has a primary key? Yes, it's auto increment. Does it have any repeating data? No. The third one is again a combination of and this is the first case where you've seen all the fields together is a primary key. There are only two fields in the table, but both of them make the primary key, and it's a composite primary key. So now if I try to put 13 or something, it won't work. We already know because it's a foreign key. And when I show all the tables, let's try to remove this select. I don't want to do it. You can remove it just because I'll do it with you now. So then I show you all the tables. Now, if you look at all the tables, query interrupted. Why was it interrupted? Must be something to do with no. You need null in a key, use unique instead. Create table colors, unsigned. Oh, unsigned null. Oops, when I was removing it, I think I left the word null in it. By chance, no. Where is the color? Yep, oops, sorry. I left the word null. I was removing it, not null. I was removing the not null and I left the null. Okay, let's try it again. Okay, it looks okay. The first table looks quite good. The second table is quite understandable, but here is the problem. What is this table? Like I have no clue. Now, if I wanted to know which toy is available in which color, I'm looking at this table and it's not telling me anything. But now you can do it. You know your joins and subqueries. What is your aim? Your aim is to join the tables and see which toy is available in which color. Now that you know joins, you should be able to do it. So let's write it. So I'm going to select the toy and the color from the tables, table toys and table colors. Right? Such that where, because of the comma, I'm using the where. You can use inner join. I'm just doing a join because that's what I'll do, right? So take your toys from the table toys, take your color from the table colors, and you need the third table because there is where the information is which toy is available in which color. So that's my third table to be joined. I'm just joining the three tables. Now what? Such that the table toys, let's give them names since if we need them. Let's call them T, C, and TC. And what should be your joining condition? Your joining condition is that T's dot toy ID should be equal to TC's dot toy ID C's dot color ID should be equal to the TC's dot color ID. Job done? You'll say, oh, that's more work, but that's first normal form. So you shouldn't have started with not the first normal form. I already told you the problems with the first normal form. So if you created a table which was not in the first normal form, ultimately you'll have to do all this work, right? So it's better that you do the right way. As I said, the foundation has to be strong and correct if you want to build upon it. Now, if I do this and I run this code, I see a table which makes more sense to me. I say, oh, wiffle ball is available in white, so is yellow in blue, frisbee in yellow, and so on and so forth. And now you can answer any queries. Like I can make this a view now because it's a useful view. You can create a view out of it. You can create a view out of it since you know about it. And you can say toys and colors. Call it toys and colors. We'll start with the word view. I don't know what the shorthand is. I think it's VW. I've created a view here. You could create a view as your select statement. And now if I say, oh, show me the toys that are available in, what isn't it like? Oh, the word as is missing. Okay. Now I want you to show me the toys that are available in white. What do? I just use the view. I say use the view, select the view toys color. So see what I've done. I've kind of created a view because it was important for me, like in the sense because I'll be using it all the time. So I just joined the three tables and created a new view out of it. Not a table, a view. And now if I wanted to select, and it has, what does it have? It has a field called toy. It has a field called color, right? And I'm only interested where the color is white. Select star from this view where the color is white. I know the fields. I think white was in small or short, whatever. Here, toys available in white color. So you created a view, a definition, because you know that you will need these three tables all the time, right? So you created a view out of it. And now, once I create a view out of it, there, yo-yo and wiffle ball are available in white. And I can now use the view as if it was a table. Or if you want to say what colors is the yo-yo available in. What do? You again do the same thing. And I'm only looking for kite. So where the toy is equal to, where the toy is equal to kite. It will tell me what are the various colors for kite. Simple. Right? Job done. So the view has created a definition of the combination of the three tables just because I needed them. And I have all the information that was available in the other table. I have everything. I can just say select star from view. If you want to show everything, like I was doing before, you just say select star from view. And of course, you can see which toy is available in which color. There it is. So now you can kind of work with it as if it was a table. What did it do? It did one important thing. All my tables are in first normal form. Want to add information about a new toy? Goes in the toy table. Want to add a color that the company is thinking of launching, hasn't yet made any toy in it, but it says, you know what? The orange color looks to be very attractive to children. So we are going to add that color. Add it to the color table. Maybe there is no toy yet in that color, but at least I can add the information that orange will now be one of the colors. The company does not make baseballs yet, but is going to kind of thinking about it, information about that can go in the toy table. Maybe it hasn't decided what colors it will be available in yet. So you don't put anything in the third table till there is a combination of this toy is available in this color, but information about toys can go in the toys table, information about colors in the colors table, even though no toy in that color is available yet. See, so it makes it simple, right? It makes it so simple now. Selections, insertions, deletions are flat and correct. No ambiguity, no double checking, no problems about extracting data, splitting it up, nothing. And if you need something badly, that means you need the combination, just create a view out of it and use the view everywhere. Because view is just the definition. Job done. Simple, right? So that's first normal form. And we have been till date creating all our tables in the first normal form, except the first one, that the favorite sites one, the week 1, if you still remember, it's week 13 now. That was the only table that was not in the first normal form because it had repeating data in its favorite sites. But it can be done. All I did was I split it up. I split up the table, right? Okay, so let's save this and let's go to the second normal form and look at something that is not in the second normal form. And then talk about what are the problems if a table is not in the second normal form. The definition of the second normal form is that a table is in the second normal form if it is in the first normal form. It has to be. And every non-key field, that means a field that does not take part in the primary key, is completely dependent on the whole primary key, not on any part of it. Right? I'll give you an example. And we'll see the example first and then come back. Okay, so I have, again, 2 tables here. I have a table called toys, which again, I'll kind of make it int unsigned just because it makes more sense to have unsigned keys. And auto increment, I've removed the not null because it is by default the primary key. So that looks to be in the first normal form, no big deal. Toy ID is the primary key. Toy is the only other field, doesn't look any repeating data in it. So that's in the first normal form. And I've put some values into it, like I did before. Look at the second table now, which I've called table toys other, just because I'm going to change it. That's not a good name at all, but I'm saying all other information is here. And look at this table. This table has an toy ID, which is unsigned. It has an unsigned toy ID, which is drawing its value from the toy ID of the other table. It's a foreign key. We all know what foreign keys are. You're only keeping information about toys that exist. You can't keep information about toys that do not exist. Then I have a store ID, which again should be unsigned. So let's make it unsigned. Store IDs are not signed. I could have made it auto increment too. And then the inventory, which should again be unsigned. Wasn't thinking about it when I was doing it maybe. And then the store address of this particular store. Okay, now let's look at the data first and then decide which can act as a primary key. Now a toy ID can occur more than once. So that cannot act as a primary key. The store ID can occur more than once because yo-yo may be available at Toys R Us and so also wiffle ball may be available at Toys R Us. So the store ID can be the same. So that also alone cannot act as a primary key. Definitely the store address cannot act as a primary key because I see duplicates here. Because store ID 1 has the address and the store ID 1 again will naturally have the same address. And the inventory, though it looks unique here, you can make inventory the primary key because Walmart may have 5 of the same thing and Toys R Us may have 5 of the same thing. You can make it the primary key. So what are we left with? We are left with combining the toy ID and the store ID to make a primary key. Now, this is an example of a composite primary key. This primary key is composite. It's a composite primary key. And it's only when the primary key is composite does the second normal form definition make sense. If it was a single field as primary key, it would not make any sense at all because we are talking about it is not dependent upon part of the primary key. Okay. Now let's look at these 2 fields that are not a part of the key. And the definition says every non-key attribute is fully dependent upon the primary key. It's not dependent upon part of the primary key. So is inventory dependent completely on the primary key? Of course, yes. Wiffle ball in Walmart is available in quantity 5. You need that 2 pieces of information, which toy in which store is available, how much. So it's not on part of it. What about store address? Does store address have to do anything with the toy ID? Nope. Store address is only dependent upon store ID. Address has nothing to do with the toy ID. A store exists on Bayfield has nothing to do with what toys does it carry. So this table is not in the second normal form because the store address is dependent on part of the primary key, since it only depends upon store ID. You'll say, but what's the big deal? That's fine. What's the problem? Let's look at the problems now. Now suppose a new store comes up and that new store is not selling any toys right now, but is coming into business. So it's being built here somewhere in Berry. It has an ID. It has been given an ID by the government or whatever. It has an ID and it has an address, but it still does not sell any toy yet. I can't put that information in that table. I cannot, because I need a toy ID with it. Suppose a store is going out of business, or not out of business. Let's say it stops selling yo-yo for whatever reason. It says, oh, I don't sell a lot of yo-yo. I always have to kind of send them back or put them on sale. I don't want to sell yo-yo anymore. So if it's the only toy it is selling, that particular record is deleted from the second table. The information on the store is also lost. You've lost the information that this store ID has this store address. You've lost that information also. So that's strange. I've lost the address of a store which was in business, but for now is not selling any toy, may come back in business. So I've lost that information absolutely. 3, update. Suppose I want to update that store number 1 has changed from 23 Maple to say 29 Maple for whatever reason. Now this information is present at more than one places, and duplicate data will always cause a problem. The first record gets updated, and between the first update and the second update, somebody selects that data. He or she will have wrong information. So data integrity is lost. You could lock the table before updating it, but what if you can't lock it? What if the table is required 24/7? You can't lock it to update it. So for updations, since the data is present at more than one places unnecessarily, you may have loss of data integrity. So you may delete the last store address of a store if the store isn't selling a toy or not selling that particular toy. You've lost that information. You may have problems with data integrity if you're trying to update the data and between the updates, somebody selects the data. So there are problems. So what is the solution? Change the table into second normal form, right? So since there are, and there will always be, duplicate data anyway always causes problems. Wherever information is duplicated, it always causes problems, right? Because if one is updated and the other is not updated. So all information at the college is only at one place in a database. Blackboard is also retrieving it from the same place. Banner is also retrieving it from the same place. Registrar's office is also retrieving it from the same place. Why? For whatever reason you change your address or your personal email or whatever, or you change your program, who's going to say, oh, this student's information is present in 3 different tables in the college and has to update every table where this information is present. So duplication of data is never a good idea, ever. Because it always creates loss of data integrity. And data integrity means accuracy or its usefulness or its reliability, right? And therefore, we will have to change this table, which is not in the second normal form. So it will run. I mean, it's just a normal program. It should run. It will give you the tables. The tables are not bad. You can look at the tables. This is your first table. It's giving you the description. This is your first table. This is your second table. and it looks okay. This toy, though you don't know what's toy ID and what is store ID, they don't give you names, but there is ambiguity here as to, oh, what if I want to change 23 maple to 26 maple and it's present at 2 places? And the last one is just showing you the tables. So now your aim is to change this table. So the first thing to understand is you only talk about second normal form when the table has a composite key. Otherwise, if it has a singular primary key, then where comes the question of dependent upon part of it? There is only one field in the primary key. So it's when the PK is composite, that's when second normal form makes sense. So again, all tables that you've done till date, except one table in the last question, they were automatically also in the second normal form because there was only a single primary key. So the second normal form is only comes into action if the key is composite. So if you want to make a note, I'll make a note here and I'll put it back on blackboard. The second normal form is relevant if and only if the primary key is composite. If it is atomic, singular, right? If it is atomic, then basically second normal form doesn't have anything extra from first normal form, right? Then, I mean, if it doesn't make sense if it is atomic. It doesn't. It's only composite. So when is a table in the second normal form? If it is in the first normal form, it has to be in the first normal form. And every non-key field is completely dependent on the whole primary key. Completely. Not on any part of it. So now think about it. What should I do here? How should I take this table and break it up so that this table becomes in the second normal form? Think about it. Look at the fields. I have a toy ID, I have a store ID, I have an inventory that only depends upon, it completely depends upon the primary key. And then I have a store address that only depends upon the store ID. What do you think? What can I do? Any ideas if you're listening to me and not laughing on your own jokes? What should I do? If I take away the store ID and the store address from this table, I'm good. I'm left with toy ID, store ID, and inventory that can go into one table, and the store ID and the store address can go into the other table. I've removed the store address, which was only partially dependent, but it was dependent on the store ID. So I moved that too. I left the store ID here because it was required here also. So let's do that now. So let's go to the second normal form that are already in second normal form and create these 3 new tables. The first one was okay, no problem in the first one, except that we have to make it unsigned. Remember, we are kind of removing that not null because it is not required, and we are making it unsigned. 2, I'm going to create a new table called table store info. I'm going to make it a primary key, and I'm going to give it an unsigned int. You could have made it auto increment also, but I just left it as 1, 2, 3, 4. You could make it auto increment, doesn't matter. If it doesn't matter, store IDs are usually given, it's a number given by, I'm assuming by some source, right? So example, you have a shop in Bayfield, you're given by some authority, a number is given to you, like your license plate, I'm assuming. So I didn't make it auto increment. I just said, okay, I'll give it 1, 2, 3, 4 to be easy, of course. And now what does this have? It has a store ID and it has a store address. Look at it. I want to change the address of 1 from 23 Maple to 26 Maple. I only have to do it at one place. A new store is coming up in Barrie. It still doesn't sell any toys. I can add the information here without any problem. A store has stopped selling toys. The information can still stay here if you like for future, or you can delete it from one place. Right? So everything is only at one place now, and there is no duplication of data. And the third table now is left with 3 fields. The toy ID, which is unsigned, just because I made the other unsigned. the store ID, which is unsigned int and is drawing its value from the store information table, and the inventory again should be unsigned because inventory can never be negative. So my third table, so my one table again has been broken up into two. It could be 3, 4, whatever it is, but I've split it. So the store ID and the store address go into one. The store ID, toy ID, and inventory go into the other. So I think I had already done unsigned inventory here also. Yes, I have. And now look at the tables. This is I mean, of course, it doesn't make a lot of sense. 5134 is telling me nothing. Right? 5134 is telling me nothing, though it says this toy is available in this store and that's its inventory. But I can always, again, combine these tables, create a view and use the view. Or even if I don't have to create a view every time. You can join or do whatever with the tables. But if you wanted to, you could create a view of all these 3 tables and it will still work. The information can all come in together. So you can say, okay, select everything from one field, select everything from the other field, and select everything from the third field and create a view out of it, right? So as such, it should run. But now comes the big question, how do I do selections from it? This table looks okay. Here, this table looks okay. I can make quite a bit of, conclusion from it. This table looks okay. This one, sorry, this store is at this address, but look at this table, doesn't give me, they're just numbers. But numbers doesn't mean that you can't interpret them. Now you know your joins and subqueries. Why don't you join all 3 tables, create a table that will give you all the information whenever you need it, right? So let's create a view on it. Let's create a view on it. And you don't have to necessarily create a view. I am only creating a view so that I can show you the combination. Let's create a view. Let's take all the 3 tables. Let's call it view. And it is toys and stores. Right? Let's create a view and it will be a select statement. And I'll do it just an inner join. I mean, if it's a question that has nothing to do with joining all 3 tables, you don't have to. So let's select. Oops. Don't know how that happened, but anyway. Let's select, just doing a tab. Let's select the toy ID and the toy from the T table. Let's select the store ID and I mean, I'm just showing you that you can still answer all your queries that you would have answered from the first one. Though there were no queries there, but I could still, I can create a table that will work perfectly fine. And the store address from the second table. And I can select the inventory from the third table. And the 3 tables that I am interested are the table toys, the table, here are their names. So here are the names of the tables, just so that I don't have to write them again. Here are the 3 tables. And what is your joining condition? Your joining condition is where. Okay, so the table toys you've called T. And table store you've called S. Oh, there. This you've called S. And what you have to now do, the store inventory, we'll call it SV or SI for store inventory. Now, what are your conditions? Your conditions are T's dot toy ID is equal to SI's dot toy ID. And your second condition is your stores dot store ID is same as your inventory SI dot store ID. I forgot my as again there. Right, and let's delete that and there. So what do I have now? I have a combination. I've joined my all three tables. But again, remember, you don't necessarily have to create a view. I'm just creating one to show you that I can have the same information what I had before. But you can do your normal joins and subqueries on these three tables. I mean, if you're only interested in which toy is in which store or what is the address, anything else is available. But to show this just says that now I can, if I like, I can say select star from a table. And this information that you were seeing in the previous one will be available here too. So if I do this, I create a view. I didn't drop the view. Oops. Unknown column s dot store ID. What did I call it? I'm sure I called it store ID.
You spelled store wrong.
I spelled it wrong here.
Yeah.
Oh, there it is. Thank you. Store ID there. Right. So let's. Oh, now again it will say maybe the view already exists. No, it doesn't. Okay, because it never executed it. And look, all that information you had before is also available here. It tells me store ID has this address. It tells me wiffle ball is available in 34 inventory at Maple Store. Like you can kind of have all that information that you had before. So toy ID, toy, store ID, store address, and then inventory. And if you like, you can order it. You can order it by store ID. You can order it by toy ID. It really depends on you. There's no big deal at all. Or you can order it by toy store or store toy. I mean, the view is just like anything else. If it makes it easy, easy, just order it by. And maybe you want to order by, I don't know, within the toy ID in store or within the store by toy, whatever you like. Oh, it already exists. So I forgot, when you run it again, definitely you have to drop it. So drop view, if exists, views to a store. Just because we keep running it over and over again, we have to be careful about this. Let's run it again. And now you will see the results in a little more, easy way here. So 62640. So what did we do? We did, I forget, 2. So store ID should come first. Oh, something is wrong then. Oh, I've done a wrong one. It is 1, 2, and 3. So it's not 2 and 1, it's 3 and 1. Sorry about it. It's 3 and 1. Because it's now doing it by toy. And that was not my intention. So see, all store 1s are coming together, then 2s are coming together, then 3s are coming together, then 4s. And within them, 5 and then 9 and then 6 and then 9 and so on are coming together. So this is giving you information about stores together. If one store is selling more than 1, so 1 is selling 5 and 1 is selling 9, you have 1, 1, 5, 9. You have 2, 2, 6, 9. You have 3 for 5 and for 4, 4, you have 6, 12. Just makes it easy to read. And of course, it will make it more easy if I put the fields together. I just went in the sequence. All information is still available. And you can do whatever you like from this view if you want, or even if you don't want to use the view, you can use any other table. Like if you were only interested in using the store ID table, that's all you have to do. You have to pick it from here and you have to get it from any other table. So this view is just like you combine the three tables, and now you can work with this view in whatever you want. So if you wanted to test whose inventory was greater than, select records with greater than, anything that's, so they want to kind of less than 10, let's say, and oh, we have to reorder for reordering or something. All you do is this, you select, and maybe you're not interested in everything. You're only interested in toy, store, and inventory. So we are saying select the toy. I think that's what we called it. We said store. Let's look at the fields. We don't know the fields. Store address, toy, and store address. Okay. So I'm just selecting the toy. You don't have to select everything. The store address and the inventory from the view. Where the value of inventory is less than 10. There. No big deal at all. Now everything that has an all, just toy, store address, and I only will have one answer, but there it is. It's telling me, oh, kite is under stocked in this store address 1902. So they need to buy more, right? So for reordering, you can do this. For restocking. So anything that goes less than whatever. And again, nothing stops you. You didn't have to use the view. You could have done a normal select statement from all three tables. Because I need the toy, it is coming from the toy table. Store address is coming from the store table. Inventory is coming from the third table. So I will have to join the three tables. I already have joined them and kind of given them a name. So why don't I just use it? If you don't, you can do normal selections also. Nothing stops you. You want to select something from the toys table and something from the inventory table? Sure, go ahead and do it. But here, because the store is important, we are trying to work with all three tables. Make sense? There it is. You can answer all the queries that you would have been able to answer in the first, not second normal form. But the main thing to be understood is that there are no problems of selections, updates, or deletes. We've taken care of integrity of data, always correct. Data is always correct. No duplicate data. Updates are easy. Deletions are easy. I can change information. I can insert information without even a store selling a toy, for example. Insert information about a new toy. It is not yet being sold by any store. All that can be done very easily. And that's the aim. What is it? CRUD. Create, read, update, delete. Those are the 4 operations you do on a database. If those 4 operations are efficient, that means your design is good. Right? Okay, let's look at the last table now. I couldn't find it with toys and whatever, so I went and just created a new one. So now I want to create a database and tables therein. There is only one table actually. All tables are in all the tables. There is only one table. The table is in the second normal form, but it is not in the third normal form. So now let's look at the definition and see why it is not in the third normal form. So I just create it, and here is the table. So I've created a books table here. The books table has an author. Every book has an author. Every book has a title. The book is published by one particular publisher. The same book is not published by more than one publisher. So I have a pub ID here. I could have a pub address here also, and so on. But I just set a pub city here, and it tells me where is this publisher situated, right? Okay, so now the key of this table before I do anything. Only author will not work because author writes many books. Only title will not work because titles can be duplicated within different authors. Intro to Java written by somebody, intro to Java written by somebody else, intro to Java written by somebody else. Though it's not usually the case, they usually keep it different, but anyway, but it could be, right? I've seen a book called God Will Never Help or God Does Not Help, and it's been written by many, many authors. pub ID cannot act as a primary key, definitely, because a publisher publishes many books. And the pub city cannot act as a primary key because the same publisher can be in the same city. So two options. You could have created an auto increment primary key in this table, which was the easiest thing to do. Or two, because I want to do a composite primary key again, just so that I can tell you, oh, is it in the second normal form or not? Author and title combination together can act as a primary key. An author will never write the same title again. If he writes the same title, it is always changed, updated, or second version, something like that. The title always changes. He can't say intro to Java. It's never, it doesn't happen, right? So an author can write the same book, but he can go something like Intro to Java 2 or Intro to Java Revised or something, or Comprehensive Intro to Java, something like that, but it will always change. So I've taken this as the key, as the composite key. Now let's look at whether this table is in the third normal form or not. So a table is in the third normal form if it is in the second normal form. That's the first thing. That means also in the first. And every non-key field is directly dependent on the primary key. When I say directly dependent, I mean there is no transitive relation. And let me show you what is this transitive relation that I'm talking about. Is it in the second normal form? All non-key attributes are fully. Actually, it is not even in the second normal form. It's not even in the second normal form, to be very truthful, because the pub city is not dependent upon the primary key at all. The pub city is only dependent upon the pub ID. The city is only dependent upon ID. The publisher city is dependent upon the publisher, not on the author or the title of the book. So this is not also not in the second normal form. We should have first changed it into second normal form. And to change it into second normal form, I'll have to remove it. I'll have to remove city altogether, which actually is not even in the second normal form. It is not. So we'll just say the table is not in the third normal form. And if you look at the definition of the second normal form, it's not even in the second normal form because pub city is not dependent upon the primary key at all. Talking about partial, it's not dependent at all on it, right? So table is in the second normal form if every non-key field is non-transitively or dependent on the primary key. Here, the table is not even in the second normal form also. But look at pub city. Pub city has nothing to do with author or title. No relationship at all. It has only to do with publisher ID. So how will I break it up? I'll take the publisher ID and the publisher city in one table. And I'll take the author, the title, and the publisher ID in another table. Right? And they will automatically become in second and third normal form. So you can make a note for yourself. Actually, it is not even in the second normal form. It's not a good example I picked up. I just realized it. But anyway, at the end of the day, we will make it in the second normal form and the third normal form. No worries. Anyway, so here is the data. The data is telling you this book was written by this author and the publisher ID is 2 and the 2 stays in New York, 5 stays in Boston, 3 San Francisco, 1 in New York, 1 in New York. Again, see duplicate data. Want to change information about this publisher ID? He's changed his city for whatever reason from New York to I don't know any other city. We have to change it at 2 places. I want to update data, again duplicate data. So the same problems that arise in second normal form still arise in the third normal form. So whenever there is duplication, or suppose I want the new publisher, suppose I start a publishing company. So I'm given a publisher ID and I am here in Barrie, but I've still not published any book yet. It takes time to publish books, right? But I've gone into business. I can't add my information unless I publish a book. So I'm kind of nowhere. A new publisher cannot be added till the publisher really publishes a book. So I can start a business, but doesn't mean I'll start publishing right on day one. It takes time to publish books. So I can't add that information. So it's no good again. If a table is not in the third normal form or not in the second normal form, it is no good again anyway. So this will work. It will show you in the sense that, oh, this is what it contains. Oops, error code, you have an error. Oh, because it was highlighted. And there it is. It's telling me this is the author, this is the title, this is the publisher ID, this is the publisher city. But again, back to square one. Duplicates, deletions, updations, everything will, all these operations will create problems for me. I can't even insert data about a new publisher. I cannot do it, right? So what should I do? Change it into third normal form. And to change it into third normal form, what did I do? I created two tables. Oh, did I make it unsigned? Publisher ID was unsigned. Okay, makes sense. It was unsigned. So in the third normal form, what am I doing? I'm putting publisher ID and publisher city in one table, and I am putting the rest of the information, author, title, and publisher ID, in the second table. Now these tables are in the second normal form also, and they are also in the third normal form. So the table is in the, not all tables, the table is in third normal form. Definitely, if it is in the third normal form, it is automatically in the second normal form also. Right? Now there is no ambiguity. Look at it. What is the key? Pub ID. What is the only other field? Pub city. Is it completely dependent on the key? Yes, because like it's completely dependent. Is there any transitive relation you see? No. So in the third normal form, the key need not be composite. It's the non-transitive relation that you are interested in. Your primary key could be a single field, right? Your primary key could be a single field in third normal form. So again, if you want to make a note in the third normal form, it's not a requirement. The primary key, the PK, can be atomic or composite for third normal form table. It's not a, it's not as if, oh, it is composite only, then should I check for third normal form. It can be single and the condition may still not hold. In the second normal form, you only check if the primary key is composite. But in the third normal form, it can be atomic or it can be composite. What shouldn't happen is this: no transitive dependency. So A is dependent upon B, B is dependent upon C. So there is an indirect A on C. That's not what should happen in third normal form. So now in the third normal form, what did I do? Publisher ID, publisher city in one table. Is it in the first normal form? Yes. Is it in the second normal form? Yes, because the key is unique. And is it in the third normal form? Yes, because there is no non-transitive relation here. Right? Let's look at the second table. The second table that I created is this: author, title, pub ID. Is it in the first normal form? Yes, because I have a key and there are no repeating groups. Is it in the second normal form? I have to be careful. Is pub ID completely dependent upon author and title? Yes, because a publisher always publishes a author and a title book. A publisher has to have that complete information. Oh, I'm publishing this book by this author. So it is completely dependent, right? So that dependency is complete. And do you see any transitive relationship? No, there is no other field with transitive relationship. So now both these tables are in the third normal form, and definitely in the second normal form, and automatically also in the first normal form. Now if I wanted, I've put in some data, and now you can answer questions. Like here, I didn't make a view. I could have made a view, but look at what I've done. I've created display the city, book information of all books published by publisher ID 1. I just did a normal select. All books published in New York, just did a normal select. But if you wanted to create a view, so I'm telling you, you don't have to create a view, but if you wanted to create a view of the three tables and call it view, and what was it? We have books basically. So we'll just call it books. View books as. You can do it. You'll say, oh, I have two tables. I just want to kind of keep them together. So you do a select. You select your author, title, pub ID. No, we have 3 tables, right? We have 3 tables. We don't have 2 tables, we have 3 tables. Anyway, author is coming from the first table, title is coming from one table. Now we have to be careful. There was a pub ID in table books, and there was a pub ID in table publisher. Okay. So joining condition needs to be done. So we'll call it P for publisher, table publisher, okay? And I'll take the pub ID from there and the pub city from there. Really doesn't matter. You can use it from the other table also. Now, what are the 3 tables? The 3 tables are table books and table publisher. Table books and table publisher, table books and table publisher. Table books, I'll call B. Table publisher, I will call P. And as I said, this pub ID could have come from B also. Not necessarily from P, but because it's kind of coming from the publisher more importantly. And then now your where conditions. Okay, so where what? B dot publisher ID. B dot publisher ID should be equal to P dot publisher ID. There, I've joined the 2 tables, and now you have the same information that you had before: author, title, publisher ID, and publisher city. And you can sort it if you like. You can sort it by publisher ID if you want. Oh, when I say sort, I mean order by. Depends on you. It will just make it clean to read. It will just make it clean to read. And now let's do a select. It was called view books. You can give it a better name. I just called it view books. You can call it view books publisher, just because it has more in it. Again, giving good names always helps to kind of say, oh, what does it contain? What information does it contain? I can do a star. Let's, semicolon is missing. I've created a view of everything. So if you could, oh, again, let's do a drop just in case. And remember, this course is not only about SQL. You will need SQL everywhere else. You will need it in Java. You will need it in PHP. You will need it because what is it? You will always be connecting to the database. So when you connect to the database and talk to it, you need SQL statements, right? So if you need SQL statements, you have to know SQL. So irrespective of, this is just a course that just doesn't sit alone. You will learn how to connect to database in advanced Java. You will learn how to connect to database in PHP programming. You should. I mean, how else will you work with databases in any language? So SQL will, these statements that you've learned, your select statements, your insert, everything will be required in every language, even in Python. In Python, I was just teaching my other section how to connect to a database. I required SQL again, right? So these statements are there forever. Okay, so let's save this. Let's run it. And if no errors have been made, let's look at it. So result 1 was just, I think, the tables. There, that's my first table, publisher ID and publisher city. That's describing the books table. That's my second table, which has a publisher ID. This is my view, which is so clean. So I'm saying this author, this title has been published by publisher ID 1, and there's the city where they live in, and the city where they live in, not live in, where they are situated, the city where this publisher is. So it's kind of easy, done. The whole table is back again by just a view. You could work with the view if you want, or you can write independent statements also. Like here, I took the title and the author. I could have taken the title and author from here, from the table. So views can be used, but that doesn't mean, oh, that's the only way to use it. You could be writing like it's the same. I'm still doing the same thing. See, this selection, this joining condition is still the same. I could have done the same from the view, author, title, and publisher city. So you could have done it like this, or I could have said select, same what you've written from the view. It will give me the same result. So instead of from, I could have said from the view. Oops. So the view was called view books publisher. So there is no rule which says you have to use the view. There is no rule which says you have to use the view. But you could use the view also. Don't assume that, oh, I always have to use the view. You can write your independent statements as if you were writing a select clause. They're just tables. Did you ever create a view on all that joins that you do till now? No, because everything was different. Like you had so many different queries. But if you wanted to, you could use the view and you would get the same answer in both of these. Oops, something is wrong. Unknown column table books in where clause. Oh, now we don't have this where clause because the view is called whatever it is called. So let's run it together. Copy and paste without doing the check. There it is. Same answer, right? But now using a view. And similarly, you could have used the view here. It's a subquery that I've written, but I could have used the view again. It needs the title and author where the city is New York. So again, let's do the same thing. Let's use the view. So you can do whatever you've learned. You can write a subquery. You can write a normal. You'll have the same answer because the joining condition was the same. You're using both tables. Here it's a subquery, but you're still using the two tables. So I should again have the same answer. So here are the publishers who live in New York. I mean, they're coming twice, but the title and the author that were published in New York. And here again are title and authors that were published in New York. Same answer. So, I mean, you can still do everything that you were able to do before, but the main thing is you have a good design. And that's very important. That is the most important thing in database before you start building your tables. So the course was not about normalization. The course was about teaching you SQL, which I did. But normalization is an important concept of designing the right tables. I just used the right tables. Leaving one of them was not good. I remember I mentioned it that this table is not the perfect table. But otherwise, I kind of used the right tables. But unless you know normalization, you cannot be a good programmer if you don't understand these concepts. And maybe you don't bother. Somebody will do it for you. They'll say, here is a good design. Now you can code. And that works perfectly fine too. So a database developer is different from a database programmer. They are two different expertise, right? But can be combined. And as a programmer, you should know some basic rules or basic concepts of designing a database, a relational database. That takes care of your course contents for this semester, right? So we've covered everything that I promised I would cover. So I'll see you next week with your final exam or your assignments. You can bring notes if you like. You'll be allowed your assignments or whatever works for you will work for me. That's perfectly fine. And we'll see how it goes. Okay. Okay, so I'll put this on Blackboard for you so that you have it.
Yeah, that's all I have left. did the NPC. I did it just because I needed all this work. A lot of these. I don't need to well at that stuff. I tried to every C when he gave us the assignment, and I'm like, fuck this, I'll do it myself. And I was like, trying to do switching it over to make it work. It's like, oh.
Noel was freaking stressed out last night. It's like, but if you do it like step by step, it's not so bad. It's like nothing works.
I was ecstatic. Yeah.
I haven't even. Not even touched it. Let's log in right
My login kind of, I don't think I'm gonna actually get it to work. You might be a little.
Yeah.
Yeah, sure.
Except in PHP, you can see like when you have an arrow. There is a line across. But here you can, right?
Come again, come again.
In PHP.
In PHP, yeah.
You can see like, for example, when you have an arrow, you see
The line number.
the line number.
Okay, so
you can see.
click on that error. Double click on it. Does it take you out anywhere?
This is the version, right? The version of that software. The version here is I think it's 8.0. Because it's error code
Yeah.
11.46, but it
Doesn't make a lot of sense, but you should be able to see it. I think I thought if we clicked on it or double clicked on it, it kind of
Oh yeah.
highlighted it.
I see.
Oh, I saw a blue thing there. No, that's a comment. So just click on it, click on that. Just see if anything is highlighted here. I remember that you were able to see it. I could be wrong, but so I mean, of course, you don't want to kind of, but it's in the select statement somewhere, and it's telling you, it is telling you this view does not exist. So it's making sense. It says this view does not exist. So here, view books, publisher.
Maybe when
No, in the select statement. The problem is in the select statement. Look here, this is the select statement. So go down. Here, select star from view books published. So I mean, you can guess, but I think you were able to see. I forget now, but if I find it, I'll tell you, okay?
Okay, perfect.
Okay?
Because you can imagine like.
Yeah, you can keep looking for it. Yeah. No, I'm sure it highlights it or something, but I forget now.
Okay, no problem.
Okay, take care.
That would make